This is what week is this? Week 5. Individual observations and attributes control charts. 571. Actually, though, I was talking about autocorrelated data at the end of last week, and I promised a way of dealing with this problem. So, control charts with autocorrelated data. So I'm going to fix this and then move on to individual observations charts and attribute control charts. So Ryan, pages 359 to 363 have reports on some simulation studies. And the upshot of these studies is use a correction factor that depends on rho when constructing an X chart. And you're thinking, oh, well, he meant an X bar chart. Well, heads up into the next topic, and that is if subgroup size n equals 1, just one observation in each subgroup, an X bar chart is called an X chart. So they just leave the bar off. AKA an individual observations chart. But more on an X chart real soon. So there's been a little bit of work on how to deal with the fact that you have autocorrelated data, but you're using control limits that are assuming independent sampling, i.e. zero autocorrelation. Well, Michelson in 1994, both of these are in Ryan, and Zhang, 1997, did the heavy lifting, and they did the simulation that showed how to correct for the problem of the control limits are too wide with correlated data if you use the Shewhart control limit formula. So, problem. If rho is not equal to 1, I mean not equal to 0, lag 1. Then Schuhart control limits are too wide. And this assumes sigma x is known. So if you know sigma, you don't have to estimate it, and you use x bar plus or minus 3 sigma x for the lower control limit and the upper control limit, then you're going to get limits that are wider than they should be for the desired false positive rate of 0.0027. So if you use this formula with correlated data, autocorrelated data, then the false positive rate is lower than 0.0027. How could the false positive rate be made lower? Just take the control limits and spread them. Now it'll be harder for the chart to squeal to give you a false positive, because the excursion in the process, the value of x that would be needed to be above the upper or below the lower, that has to be a very extreme event the wider you set the control limits. Therefore, the chance that even though the mean has not changed, that you'll get such an event is made smaller. And that probability, i.e. the mean doesn't change, yet you do get a point outside the control limits, that is the false positive rate. So the problem is that if you have autocorrelation present, then your control limits are too wide. But this makes a really unrealistic assumption. It took me a while to get this straight. These two papers and the suggestions given in Ryan are only pertain to the problem of when you know sigma. Excuse, but you never know sigma. You're in the real world. You've got to estimate everything. But let's not deal with that just now. Let's first do what these guys recommend that we do. So I'll compute limits, in this case, with this formula: x bar plus and minus k sigma x gives, what's the value of k? Where k is from this table, which I will give you right now. So here's your estimate of rho, and here's the value of k. So we have 0.95, which is a radical, very high autocorrelation between two successive observations, negative 0.75, negative 0.5, negative 0.25, 0, which is the case that Schuhart considered, 0.25, 0.5, 0.7, 0.75, 0.9, and 0.95. and the adjustment factor is extreme for super high autocorrelation. Instead of using 3 in the standard formula, you use 2.53. That's going to make your control limits considerably more narrow. 2.91 if you have high but not extreme autocorrelation. 2.97. 3. Well, 3 is what we're supposed to use if we have no autocorrelation. Positive 2.99. 2.98. 2.94. So you notice as the correlation gets stronger, the correction factor starts to get smaller. 2.9 for 0.75, 2.8, and 2.54. So these adjustment factors are from simulation studies, and they work pretty well, and they're super simple to use. You just use the value of k right here instead of the value 3, depending on how much autocorrelation you have. And remember, last time we went over a little SAS program that allows you to compute the autocorrelation at lag 1. However, there is another problem. Oh no, what's this other problem? Sigma hat is negatively biased if S is used to estimate it with autocorrelated data. Actually, S over C4. That is a problem that was not considered by Michelson and Zhang and Ryan, but it can be a very strong negative bias. In other words, you will estimate too small a value of sigma if you have highly autocorrelated data. So actually, the two kind of cancel each other out, because if you know sigma and you haven't estimated it, you need to adjust down the width of your control limits. But let's say you don't adjust down and you just go ahead and use the standard formulas. Well, actually, because your sigma is being negatively biased, that in effect is adjusting down the width of the control limits. If you use 3 instead of a k that you get out of this table. But the point is that there are two problems, and they're pulling the control limits in opposite directions. So how might you go about dealing with both of these problems at once? Well, let's look at a little example that I wrote that corrects for both. So I have a program out on the G drive. Can get to it. AC chart, autocorrelated chart. So let's look at this puppy. Well, what do we see here? I'm going to simulate a data set, so you wouldn't run this first chunk of the code in real life. What I'm doing is I'm popping into an embedded programming language in SAS called Interactive Matrix Language, IML, and I'm making up some data. And if you notice what I'm doing in this loop, if you know anything about programming, I set the last value of x to Lx, and then I multiply Lx by 0.9, and I add 2 times a random disturbance to get my next value. So I'm making every value very similar to the last value, but with a multiplication of the last value by 0.9 and then some added noise. So I'm making up data. I'm simulating data. And then I say raw dat. Well, raw dat is what I created from the simulation. So in real life, you would take your data set from your real business process and you'd stick it into a SAS data set called raw dat, and this would be your first step to deal with the fact that you have autocorrelation. So your first step is you form your subgroup means. Then you compute the sample autocovariance function from the raw data to get your row, lag1. So this is the row symbol that I've been writing with the Greek letter rho. And you compute that, and notice I'm computing it using the actual formula for the autocorrelation rather than the proc ARIMA. And again, I'm using proc IML to do that. And now I say compute the standard deviation of x that correctly accounts for autocorrelation. Okay, so this is what was left out of Ryan, Zhang, and Michelson. This computation comes from multivariate statistics, so I don't expect you to know this. I certainly don't expect you to know about how to run in IML, work in IML, but I'm giving you an overview of what you would need to do to fix both of the problems. The first problem being that unless you correct for the autocorrelation, your estimate of sigma is going to be biased low. And the second problem is, with autocorrelated data, if you know sigma, your control limits are going to be too wide. So you compute the standard deviation correctly. So now you're in a situation where you have a good estimate of sigma, the proper estimate of sigma, nearly unbiased. Now we say, okay, so create a control chart limits data set, and you can correct the X charts in control ARL excuse, using the Zhang and Michelson correction factors, of which I just gave you in a table. Where did I get this table, by the way? I pulled these values out of the text in Ryan, and I looked at the papers, which are both available online, of course, as long as you're on a computer that's on the campus here, recognized by the university system, because I think one of the journals is subscription only if you're just from a computer that's not associated with the university. But anyway, I read those articles and I found all those values. So I just pulled them out of both Ryan and Zhang and also Michelson. And you have this table. So what am I going to do with it? Well, you've estimated sigma using this IML code right here. Now you want to correct. So I say you can use the estimated. You can use the correction factor by looking for the row. So this is row LG1 for lag 1. So this value is what you will use to look up the correction factor in that table. But if you're using running a good old X bar chart and your subgroup size is bigger than 1, then this correction factor doesn't apply. Well, what am I going to do then, you ask yourself? Well, that's where you either dig into this problem yourself or you hire a consultant, because this is not a simple problem. And Ryan only goes so far as to talk about how you can correct if you're running an X chart, because that's the simplest case. So up here, I say print row lag 1. So notice, compute the sample autocovariance function. I just need it at lag 1, and I print it. So you can always run this code. Once you have data from your business process, you will get row lag 1. From that, you can look up the correction in the table as long as you're running n equals 1, i.e. an X chart. The other cute thing about this example is here's a little data step which creates custom control limits for the control chart. An example of this is inside the SAS documentation, but I thought it was kind of a nice way of showing that you can indeed compute your own control limits and force them upon Proc Schuhart. This is a great example, by the way, to be shamelessly plugging advanced software. This is why you don't want to go down the road of Excel, by the way, because Excel is not easily extendable in a way that is pre-programmed. You would have to jimmy the control chart software that you've painfully written in Excel to now handle custom control limits. Whereas, if you notice how the folks at SAS have dealt with this problem, they say, well, they might want to build their own control limits. And so I'm calling it autocorrelated limits for it. So AC limits is short for autocorrelated limits. And look down here. Proc Schuhart. What's the data you want me to use? MNSDAT for meansdat. Oh, I see a limits option. Oh, what data set do you want me to use for the limits? Well, the one that I've created up here. Okay, I'll use these limits when I draw the chart instead of the ones that I would have computed internally. So X mean by subgroup, 100 panels, and let's see here. Max panels specifies the maximum number of pages or screens for a chart. Well, yeah, we only want one chart, but if for a big complicated data set, you might have to go to several pages of charts. Number of subgroup positions per panel or per individual page chart. I'm thinking 100. Whoa. Well, let's look up here at the data set. How many times did I go through this loop? I've got K, which is the number of subgroups set to 100. Okay, so I'm saying I want 100 points on a chart. If you didn't set this, I think when I tried this before, it gave me like 10 charts because it was only putting 10 points on each chart. So anyway, up here, standard deviation of X bar, STD X bar. And look, if you notice the way I've programmed this, I'm using standard plus minus 3 sigma. So this is actually no different than what Proc Schuhart would have computed. But if you had put in a correction factor here, you would have put in, say, the 2.53 here and here to get the corrected values. Well, so then I do the proc run, and let's see if I can get an output. Connecting to server, ready, running, collecting again, And we should have this pretty soon, and yes we do. So when it gives a log file first, that sometimes means it's not a happy camper. So there's row of 0.89. See, I forced it to be quite high. Subgroups, and look at that. Isn't that cool? So the control limits were computed, and we have 100 points, and look at this. Cool. The lower control limit's -11, the upper one's 12.37 via my custom control limits, and there they are. So, well, where'd you get that? Look here. Data, AC limits, and then I just say proc print run. Well, what this is going to do is it's just going to go ahead and print the entire data set of whatever data set was the most recently one created, because you haven't told it what data set. And so this is going to dump everything that got created in this data set. And sure enough, the two things that I'm looking for is underscore UCLX underscore and underscore LCLX underscore, the control limits. End of screencast.